I welcome Luciano for this podcast. This is a kind of a podcast where I'm trying to demystify something called as Node.js. It's not about the NPM package, it's not about the Maven, it's not about modules which we are covering. It's all about the development process which this technology saw. Of course, it's very related to the JavaScript, but there are humongous changes that we need to demystify in order to be a right developer in the space. So I'm glad that I'm doing podcast with Luciano. It's an honor for me to have him on my podcast as a guest. So a little insight about him. He's a senior architect at fourth year. That means he has gone through the phase of development. He has been a developer himself. So his career has seen a lot of hustle that it need and it required for him to become proficient in Node.js. So we'll be demystifying how to be proficient, at least not as a job, at least to work on your hobby projects. And we will also demystify a lot about his book. So I welcome Luciano for this podcast. Thank you for accepting the podcast.
Thank you, Vishvash. It's an honor for me to be here. So yeah, really, thank you for having me.
Yes. No, Luciano, you have seen development of frameworks in a very intuitive fashion because you have gone through the phase as a developer. Now you are a senior architect at fourth year now. So how have you seen the evolution of JavaScript or programming language from your side? Everybody has a different view. It's from the compilers that we saw the Turbo C, and we saw a huge change in how the same C compiler was being improved in a new fashion for the developers. So, how have you seen the development of the programming as such?
Yeah, no, that's a very good question. So just to get started, we have to remember that JavaScript, if I don't remember wrong, was released for the first time in 1995. So it's starting to become a little bit of an old language at this point, but it has a very interesting history nonetheless. So when it started, JavaScript was essentially like a simple way to add animations and a little bit of interactivity to web pages, nothing more than that. So it was a very, very simple language. And also a number of interesting design decisions, because at the time Java was very, very popular. Therefore the name, just because they wanted to kind of convey a feeling of, it is, if you're coming from Java, it's not going to be too much different. But in reality, there are some significant differences. So yeah, that's also kind of a misnomer in a way. There are, I think, a couple of interesting phases in the story of JavaScript that kind of made possible for the language to be very successful. At the beginning, I think the main reason why it started to have traction is because there were other initiatives like VBScript, like the Visual Basic Script was proposed by Microsoft at the time with Internet Explorer. So they were competing a little bit, but eventually the world of web development standardized on JavaScript. So that was the first, I think, milestone for the success of JavaScript. That was the official language to do front-end web development. Then I think the next interesting milestone for the language was the creation of Node.js, because at that point, the idea of Ryan Dahl was that JavaScript was a very good language to express, let's say, IO-driven type of workloads because of the non-blocking nature of the language. So essentially the idea, and this is one of the core differences with Java, the idea is that if you call an IO function, that function is not going to block. So if you have another line after your IO function, what's going to happen is that the IO function is going to schedule some task that is going to run in the background and then immediately go to the next line, which is not what happens in Java. Like in Java, if you try to read a file, for instance, when you get to that point, the entire code blocks until you actually completed to read the file, and then you can continue. So the idea of Ryan Dahl was, okay, this abstraction in JavaScript for frontend is only used to manage events in the browser, but why not using the same abstraction to create server-side programs? And he had in mind a number of specific use cases like, I don't know, TCP servers, like very low-level networking programs. And therefore, he started to work on Node.js. Then he released Node.js, and Node.js immediately started to gain a lot of traction, even with big companies. I think PayPal was one of the early adopters. So you can imagine a financial company, a big, like a giant like that immediately jumps into the bandwagon of Node.js. So they saw some power there, right? And I think at that point the history was that for at least this was my perception as a web developer, I started to think, okay, I have been doing a lot of JavaScript for the front end. I have used all sorts of framework, jQuery, vanilla JavaScript, even a little bit of React at the time was starting to be one of the main frameworks, Angular. And I started to see, okay, I'm doing a lot of PHP for the backend, but why not using the same language? Like I have a lot of experience in the front end, and every time I have to context switch between a language for the front end, a language for the backend. So at that point, I realized the potential of Node.js, and I started to read and study more and more about Node.js. So I think that was, the point where also JavaScript in kind of had a ripple effect, because since there were a lot of people investing in server-side development with JavaScript, and also was the time where single page applications were becoming very, very popular. So there was also a new wave of let's make the language better. And that's where we started to have ECMAScript 2015. We started to have a more regular pace of releases with new additions. And I think today, also thanks to async await, the JavaScript language as a whole, both JavaScript and Node.js, it's a very mature and complete language that you can use to build all sorts of applications. So I think very long answer, but I hope that answer your question.
Yes, it answers my question. But like, no, as a beginner, when we start programming, let it be a kind of a programming where we are trying to deploy a serverless application on cloud or something. There are languages like Python, Go, C Sharp, a lot of things are available. Do you feel that JavaScript should be that de facto language to start from? Because I feel it's a pretty easy one, because there are a lot of frameworks, there is a lot of community support which is available. So if there is a developer, of course, it's the most popular programming language today, as you told about the evolution of this programming language, as in JavaScript, which was first initially used for running the web applications. You said about the single page web applications and all, but should JavaScript be the de facto programming language for the beginners who want to do something apart from programming for the academic world? We have labs and we just copy the code from the lab manual or something. So, but like, do you really think that JavaScript should be the de facto language for the beginners who wants to do some application?
Yeah, that's a very good question. I don't want to say yes, even though I'm biased to say yes. And the reason why is because I think Node.js and JavaScript, they are very good languages where you have, let's say, IO bound applications. So when your application is very dependent, or most of the time is spent in doing, I don't know, network connections, reading files, so very peculiar input and output operations. In that case, I think the model of Node.js and JavaScript is very, very efficient. You have a language that can express things concurrently in a very powerful way. So you can take advantage of the event loop as well, that is very efficient. With just one thread, you can have that level of concurrency. So also, it's a language that you can use to build almost every type of application these days, because you can do front-end, back-end, even IoT, you can do mobile applications. So in a way, it is also good to know the language, because then you have a range of opportunities where you can use the language. But at the same time, there are a lot of cases where JavaScript is not the most ideal language. I know you are big into AI and machine learning. So for instance, if you have to train a model, which is a very intensive CPU or GPU operation, probably JavaScript as it is today is not the most efficient language. So I will say, yes, learn JavaScript, because once you know JavaScript, you can use it in a number of different ways, but make sure you understand what is the trade-off of the language. So you can pick JavaScript only when it's really the good choice and not use it for everything blindly.
Yeah, you told about not using this programming language blindly, because there are compilers, there are interpreters which are way more efficient than JavaScript to some extent. But JavaScript is fast. It's pretty fast. When I see, sometimes when I see the documentation of, let me just say, React Native, there is something called as port 80, which is a kind of an hardware jargon, because uh, I'm an ECE student, electronics and a communication student, nowhere related to the computer science. I can understand hardware much proficient than a computer science grad, because I have that essence of hardware in all my subjects. So, I just want to ask you this one question. How is this hardware and the software so related in terms of JavaScript, where of course there is web engines, there are JIT compilers, just in time compilers, lot of things involved. So what's actually that actual essence of concept that actually made developers to build something based on an hardware? Because I know everything that we are using in Node.js, everything goes in the form of a server and a client side application. But like, how is this mix or the combination of the hardware and software interpretation for an application helping developers today?
Yeah, that's a good question. I don't know if I am.
And I want to continue, because like, even in your books you have talked about testing, you have talked about the way in which this entire language is going to behave on the browser. You also have talked about HTTPS ports. So you can give a brief intro on what can be the future of this language also with respect to hardware optimization.
Yeah, no, that's a good question. I don't know if I am the most qualified person, because I'm not that expert with hardware. And also, I've done very silly things with a little bit of hardware and JavaScript, but I haven't used it that much. So I'm going to try to give my opinion, but yeah, take it with a pinch of salt, because I'm not an expert in this field. But what I understand is that there are some innovations in this field. For instance, I know there is the Espruino board, which allows you to write a subset of JavaScript, and then that subset of JavaScript runs in a very optimized way on that specific board that supports Espruino. So I think that may be a way to use JavaScript for hardware, but I think my understanding is that this is not something that is like extremely production ready. It's more for hobbyists. Maybe in the next few years, yeah, there will be more investment in this field, and maybe you can actually build very serious hardware plus software written with Espruino and JavaScript. But I don't know. My feeling is that today, if you want to build very solid, I don't know, maybe you are building an IoT device, and for, let's say, medical reason, just to have a specific use case, so you really want to be sure it's solid and you can have control on the hardware, probably you still want to use C, C++, maybe Rust, because you can really have control of the hardware and how the memory is used for that specific hardware. So I don't know. I think this is one of those fields where using JavaScript is a little bit of an edge case. You can certainly do it, but maybe it's not the most ideal choice. Maybe there are traps there that you need to avoid. So in that sense, we probably see in the future, if these traps, people figure out nice ways to solve them, and then it becomes easier and you have a lot of performance as well. But until then, I will suggest, yes, if you are building your own thermostat at home and yeah, you are using it yourself, yes, have fun with it. You know JavaScript, you can use it. But if you want to build an hardware startup, be careful. I mean, yeah, try to evaluate everything before you commit to that specific choice.
Yeah, no.
I hope that answers the question.
Yep, it answers the question, But like, I want to ask you this question, like, why is JavaScript or TypeScript damn fast when we compare to other interpreters? Of course, it's running on a web browser, web engines are there. There are specific compilers which are running in the backend, so that process gets faster. But why is JavaScript so fast compared to the other ones?
Yeah, I think one of the reasons why JavaScript is so fast is simply because there has been huge investments by the likes of Mozilla and Google just to make sure that the interpreter is as fast as it possibly can be, right? And there are a number of interesting talks from the V8 team in Google. If you search online, I can probably recommend some that maybe you can link in the description, where they show some of the optimization that they worked on just to make the language fast. And just to give you an example, one of the problems with scripting languages in terms of performance is that, of course, when you declare a variable, that variable can be anything. And in JavaScript, it's even worse because it's a loosely typed language. So you can say, okay, this thing is an integer. And then in the next line, the same thing is a string. So the compiler doesn't really know how to allocate the memory in the most performant way because, yeah, it can change all the time. So in the V8, I'm going to describe this very, very badly because I'm not an expert on this field. But as I understand, in V8, there are a number of just-in-time compilation strategies where the type is inferred. And there are a lot of optimization that are applied specifically to functions. So essentially, when a function is considered hot, so it's in your, let's say, most use code path, so you are calling that function a lot, the arguments of that function are inferred, meaning if you see that this function always receives 2 integers, at some point the compiler is going to decide, okay, I'm going to actually create a compiled version of this function where I am assuming this is just 2 integers, and that's going to be much, much faster to be called because there is a lot less type infer at runtime. So this is just one of the tricks that I understand that the V8 engineers have put in place for making JavaScript faster. But there is a lot of stuff. Like if you are curious, there are so many talks where they explain all sorts of optimizations that they put in place. I think other interpreted languages could be as fast as JavaScript. It's just that for the unique position that JavaScript has, many big companies have invested a lot in trying to optimize the runtime.
I wanted to ask you this one question based on testing. Actually, you know, how different is testing a Node.js app or an application which is developed on Node.js than the regular ones? Like I can say Flutter is actually a kind of an npm package only, but like it's been installed in a different fashion. That's it. But like I just want to ask you this one question: how different is testing an application that is built on Node.js different from the other languages that we have been using, like Richie Ali?
Yeah, honestly, I don't think it's that much different. I think all the standard practices apply to JavaScript. For instance, you can easily do unit tests. There are, I don't know, hundreds of frameworks that you can use to do unit tests. And with Node.js, most of the time you don't even need a framework because you have the assert library in the Node.js core. And with that, yeah, you cannot write sophisticated test suites, but you can write some minimal tests. So that all the ideas apply there for Node.js. Like at least I will say, coming from other languages like PHP or Java, you can do unit tests almost in the same way in JavaScript. Maybe one interesting detail that makes it a little bit interesting is the module system in JavaScript is much more dynamic than it is in languages like Java and PHP. For instance, in Java and PHP, you need to be very, very careful about dependency injection, like the way you structure your modules, because then when you do the testing, you need to be able to pass different implementation that essentially are mocks, because you only want to test one thing. So if that one thing relies on other components, in your test, you have to have mocks for those components. So in Java and PHP, I've seen that you are very, very forced. As soon as you start to write the tests, you realize, okay, I didn't structure my code well enough because now I cannot test this function in isolation. I need to decompose that function into dependencies and then mock the dependencies. In JavaScript, because the module system is so powerful, you can sometimes, and also the language is a lot more dynamic, you can sometimes just patch things on the fly and take shortcuts. And that way, it's kind of a double-edged sword because it can be dangerous to do that, but sometimes it's convenient. So if you use it with caution, it's convenient. But of course, don't abuse it, because then you can have your code to be very, very messy. And yeah, and eventually you can have tests where you are patching everything and you are not really testing your real code anymore. So that's maybe something interesting as a comparison between JavaScript and other languages. I think the same applies to Python as well. I wouldn't be the most experienced with Python, but from what I've seen so far, also in Python, the module system is very powerful and you can swap things when you're testing. You can do all sorts of things without having to change your code and make it more modular. So maybe this is just a comparison between interpreted languages and, well, PHP is an interpreted language, but yeah, you got me right with Java. Let's Java-based languages and more dynamic languages like JavaScript and Python. So yeah, in terms of other types of testing like integrations and end-to-end tests, there I don't see any big difference. I think that all the regular practices apply as they apply to any other language.
When we think of Appium for testing the mobile application, the Holmium, which is just used for the black box testing of your websites, all these come into the picture because these are just rolled in as a framework. There is no difference between the compiler or they can be a wrapper, they can be a framework. Do you really feel that there is way too more JavaScript frameworks than required? Because language is easy, so everybody is creating their own framework, just like Python. Just like Python. Do you really feel that there is way too more frameworks in JavaScript?
Yeah, probably yes. There is actually a funny thing that I read a few years ago. It's called the NPM game, where basically you mention a word in the English dictionary, and then you check if there is a package on NPM called that way. So you say, I don't know, banana, and then you go on NPM and check, is there a package called banana? Probably there is. So that's the intent of the game. Figure out an English word that doesn't have an NPM package already. So certainly there are more modules that we actually need. And maybe, as you said, that's because, yeah, it's so easy to publish a module. It's so easy to write one. And sometimes people just want to do it for fun because it's also a learning experience. You can learn how to write your own, I don't know, framework module, whatever. Then, of course, that it's nice in a way, but also creates a problem. Like when you are looking for a specific package to solve a problem, sometimes it's not easy to figure out, okay, there are 15 competing packages that seems to do the same thing. Which one should I pick? And there are some common sense rules that you can use to pick the one, at least, that should be reliable. I don't want to say the best one because you never know which one is the best one. But in general, all these packages are open source. So what you can do is like go on GitHub and see, okay, is the maintainer actually updating this thing regularly? Is the maintainer replying to people that are creating issues? Is the maintainer receiving pull requests and actually working with other people on them and merging them? And also there are all sorts of good practices in terms of dependency checking. Like there are a lot of tools. Even GitHub itself will tell you this package is using other dependencies that might be vulnerable. So if you put all these things together, you can probably figure out between 15 libraries which one will give you a certain level of trust, and it's maybe best using that rather than others.
We talked a lot about JavaScript because Node.js is part of JavaScript. It's from the same old generations of interpreter that this thing has been derived. So we had to clear a lot about JavaScript. So thank you for that. Let's just jump on to Node.js. Of course, Node.js has been something which is more humongous. I feel one day everything, let it be edge devices, let it be computers, somewhere or the other, when there is something called as a browser which gets somehow installed onto anything. Let me just say, just like how we have the bootloaders to just download a program onto a microcontroller, if there is something called as a browser which gets installed onto your microcontroller or microprocessor, I think probably everything is going to be run through JavaScript itself one day. I think so. That's the only key. I just want to ask you this question: like, how is Node.js working? How different is it from other frameworks or the other compilers when we consider Node.js as a complete working entity in an architecture? Let it be for an application, let it be for an business perspective where a company is trying to build something using Node.js?
Yeah, if I get your question, it's like, when should you consider, as a company, when should you consider using
Yeah,
Node.js
kind of.
as?
And also, how is Node.js working? That's my question, basically.
Okay.
How is Node.js working?
Yeah, so in basically Node.js works by wrapping V8, which is essentially the JavaScript engine that you get with
But we have Gawky and we
Google
have
Chrome.
other, yeah, but we have Gawky in Mozilla and we have also WebKit
Mhm.
in Safari. So is it the performance still remains the same in all these web engines?
I think the performance are slightly different. There has been a little bit of a race between Apple and Mozilla and Google to come up with the most performant JavaScript runtime. And I probably there are, I don't have the latest numbers, but I feel that probably there are specific areas where one interpreter will perform better than others and so on. I think all over V8 is still the most performant as far as I'm aware. But of course, there will be specific tasks where maybe the WebKit one is the most performant and the Mozilla one maybe will be the most performant. So yeah, it's always a little bit of a race, and it's always a little bit hard to say in absolute terms, this is the fastest ever, because maybe in some application, one can be faster than the other. So I think the choice there was maybe that it was the easiest to integrate V8 into when the Node.js project was started. Maybe V8 as a library was the easiest to integrate into an engine, let's say, that then became Node.js. Another thing that is very interesting in Node.js is that there is another library that is called libuv, which basically allows to do a number of things that you cannot do in the browser. So in the browser, since it's an environment that by default you shouldn't trust because you are running code that other people wrote, and you just go to a URL and this code is running in your machine. So by default, the browser has to be very, very secure. Therefore, the environment is very sandbox. For instance, you cannot write a JavaScript line that reads a file from the file system in the browser, right? Because otherwise you can create a URL and you can read everyone's file system from people visiting that page, right? So in the browser, you have no easy way, let's say, to read a file from the user disk. In Node.js, where you are actually creating applications that are server-side applications, you probably want to be able to read a file. You probably want to be able to do a TCP connection to another server, or even a UDP connection. So you want a lot more control on the hardware and the system. So libuv tries to fill that gap between regular JavaScript that is very limited in terms of capabilities and adds a lot more capabilities. And also there is a challenge there because all these capabilities, they need to be asynchronous as well to play well with the model in JavaScript. So libuv, basically what it does is an abstraction layer that gives all these primitives to the Node.js runtime. And with these primitives, you can use file system access, network access with async await. Also, interesting enough, libuv tries to make it cross-platform. So the implementation itself use different mechanisms depending on which operative system you are using, and will be able to give you the same interface at the end of the day. So you can run Node.js code in, I don't know, Linux, Windows, and macOS without differences, but just because libuv is doing all that abstraction for you. So I think the main architecture of Node.js, and don't quote me on that because I'm not the most expert about the architecture of Node.js, but the main components are V8 as an engine for running JavaScript and libuv as an abstraction layer where you can interact with the resources available in the machine in an asynchronous way. So I hope that answered the first part of the question on how Node.js
Yes.
works. Then the second part of the question was, as a company, when do you decide to use Node.js? Is that correct?
Yes, that's the one.
Okay. Yeah, this is a very good question. And I think that the standard answer, it depends, applies. I think my opinion is that in a company, one of the main factors for choosing a specific technology, actually two main factors. One is, can we find people that know that specific technology, or that they are willing to learn that specific technology? And the other thing is that technology actually worth investing on for that specific problem? For instance, again, we can do the example of hardware, right? If you're building an hardware product and there is a little bit of software on top of that, probably investing on JavaScript, yes, you can do it, but probably is not the most effective choice that you can make. Instead, if you're building a web application and you are in a city where there are a lot of full stack developers, so it's easy to hire for people that know JavaScript and Node.js, probably makes sense to invest in Node.js and JavaScript and build your application with these technologies, because then you can hire, you have a pool of experts that you can even get if you need help to train your developers. So it's probably one side, I would say it's the market where you're in. Like, in that market, can I access expertise for this technology? On the other side is, does this technology fit the actual problem? Like, is the ideal technology to solve this type of challenges?
I just want to ask you this one question, like, migrating from version of Node.js is like very difficult. I've experienced that. Let's just say like 8 to 11. It's like a huge task, because there is a lot of updates which have come up in those two versions, like 3 versions actually, 9, 10, and 11. So there's a huge gap in the version. So how can we actually migrate to one version to other so easily? Because most of the developers have this question, like, of course there is a huge change in the framework from that version to this version. How can we really migrate back? So what's that actual solution that you have, or a hack that you actually really want to say to the people that who wants to migrate from one version to the other?
Yeah, that's a good question. I think in the last few years, it has gotten much easier, because also that the language, the runtime and the underlying language and the processes got much more stable. So I don't see like migrating, for instance, as you said, from version 8 to 10 or 12 as something I would be worried about, at least for the main features of what you have in the standard library of Node.js. I think those are very well taught, and you almost never have breaking changes. And if you have breaking changes, you have intermediate versions where you get warnings, but you can still use that specific version. So if you keep always up to date, it will get easier to migrate between versions. I think one problem might happen with dependencies, because dependencies are something that other people write, and they are all, like, there is an entire graph of dependencies. So there are dependencies of dependencies. So sometimes it might happen that you are relying on a specific dependency and you are not even aware that you are relying on that, because it's not a direct dependency. And that dependency doesn't work with whatever Node.js version you are trying to use or upgrade to. So that might be a little bit of a challenge. And sometimes you have to figure out how to, I don't know, either replace that dependency or change the approach. So that might become sometimes painful. But in my experience, it doesn't happen that often. So I think in general, Node.js has today a very good process to migrate to next versions. Also, an interesting thing is that there is, and this is something that has been happening for the last few years, I think at least 3 or 4 years, there has been a very well-defined process where you have a version of Node.js that is the long-term stable release, which means that if you are building a production application, you should probably be using that version. I think right now is 12, but it's moving to 14. And don't quote me on that, we can check on the website.
Yeah,
but
it's still the LTS version which is there, but 14 is like beta version. So if you are confident about that, you can still download it. You can still install it, by the way.
Exactly. But the idea is that that version is going to be supported for a very long time. So if there are security issues that needs to be patched, that version will still be patched. So you shouldn't be using, like, I don't know, version 11, which is more of a transition version that is used for more experimental reasons where you want to use the new features, but you shouldn't be using that in production. So always pick the stable version, the long-term stable version, because that will give you a lot more guarantees that for whatever reason, if you cannot migrate to the next version, at least you are getting for a number of years all the security patches. So that's a good thing to have in a runtime in general.
Yeah, we often come across the words like patching, hot patching. It was a big deal, I think probably 10 years before, because everything was running on a server, and the server was supposed to be updated. And let me just say, like, updating the software in a server used to be an hectic job, because there was nothing called as VMs, there was nothing called as containers. So yeah, it was an hectic task. So I just want to ask you this question. Software has evolved. There has been lot and lot of jargons which are coming up. If you say Node.js, there are pretty much lot to be covered under it. It's not like jargon, but like there is a lot and lot of concepts behind it. But like, I just want to ask you this one question: how was your journey in learning Node.js effective in order for you to write a book, which is like, I just, don't judge me on this, but I'm saying it's the Bible for Node.js. If you want to learn something on Node.js, it's like everything is covered. You don't have to go for the documentation. You just can go there and you can just start working on the Node.js. If you want to understand it thoroughly to build a secure architecture, of course, Node.js has some security issues, and it also had a lot and lot of support from the community. So it's still developing. Of course, hackers can find their way off in order to get through the application. But how was your experience in learning Node.js? Like, how long did it take for you to get the semantics of this entire frameworks? How long did it take for you to understand the way in which the development process has to happen?
Mm-hmm. Yeah, that's actually an interesting story. And I think I've been a little bit lucky, so I want to tell the story. So basically, when I started doing software, one of the areas where I spent most of my time was web development. And when I started my career, web development was mostly PHP on the backend and JavaScript on the frontend. So I did a lot of that, both backend and frontend. So I was skilled enough with JavaScript because I've used Backbone, jQuery, Angular, React, also vanilla JavaScript. So I did enjoy doing frontend. I did like JavaScript, but in the backend I was using PHP because that was the most common technology used by most companies I was working with. And also, to be fair, there were a number of very good web frameworks, like Symfony, for instance, was one I did enjoy using a lot. But then at some point when I saw Node.js, I was like, okay, finally, one language to rule them all. Like if you're doing web development, you can use that one language both in the front end, in the back end. Maybe you can share code as well, because one thing I was seeing is like, I don't know, if you create a form, just to make a stupid example, you need to have validation rules both in the front end and in the back end. And then you try to write the same code in JavaScript and in PHP, and then it's never matching 100%, and it's annoying that you're writing the same code twice, the same tests twice. So I was a little bit looking forward for a solution like Node.js, where you just write JavaScript and you write it in the front end, in the back end. And if there are pieces of logic that are shared, maybe you have one file that you can use in both back end and front end. And so at that point, I started to study about Node.js. And one of the resources that I happened to read was the first edition of the book Node.js Design Pattern, where I wasn't an author. It was just Mario doing that book. And I really enjoyed reading that book. Like, that book was really well done. Already the first version was amazing. I did learn a lot with that book. And I started to do some open source projects just to kind of play a little bit more with Node.js and get feedback on what I was building on. And I think one of my first projects was a command line utility that you could use to download an entire gallery of pictures from Flickr. Because I remember at the time, if you wanted to download an entire gallery, it wasn't possible. You could just download them one by one. So one day I was trying to download pictures from an event, and it was like 200 and something pictures. So I got this idea, okay, I'm learning Node.js. I have this problem I have to solve. Let's try to write something in Node.js to solve this problem. And then I wrote like a silly script, which I still have available in my GitHub if people are curious. And it's not the most amazing piece of Node.js. It's actually quite ugly because I was doing a lot of object-oriented things that you generally don't do in JavaScript and Node.js. But I use that as an opportunity to ask for feedback to the communities. And I got in this community called, I think it was Node.js Italy, where there were a lot of Italian developers with more experience in Node.js, and they gave me a lot of feedback. And one of these people was actually Mario, the guy who wrote the first edition of the book. So I was like, oh, this is amazing. He's giving me feedback and I'm learning from his book, but he's also giving me advice on my project. And then at some point we kind of started to become friends. I moved to Dublin. I was originally in Italy. Then I moved to Ireland. I lived in another city in Ireland for 1 year. And then I moved to Dublin as well. And I knew that Mario was living in Dublin as well. So at some point we met, we kind of became friends, and he started to look at my blog. And at some point he asked me, okay, I see that you are doing a lot of technical writing. I have to write a second edition of this book. Do you want to help me with that activity? So I was super lucky, but at the same time, I wasn't super confident because I felt, okay, I know at this point a little bit of Node.js, but do I know enough to be able to write a book? So that was probably one of the tipping moments in my career, where even if I didn't feel like I was the right person to do that, I wanted to say yes anyway and take the challenge on me to become that person that could do a good job. It wasn't easy. Like, it took me, I think, 9 months to write the second edition. But at the same time, I think it was easier than writing a book from scratch because I was standing in the shoulders of giants. Like, the first edition was already there. It was amazing. I just needed to update it with the latest news of the language and also write a couple of new chapters. So that was a very good learning experience because I had an opportunity to reread all the book, but not just reread it, also make sure I understood every single detail of the book because, I needed to rewrite all the examples, make sure they did work. So that was probably the moment where I started to become more of a professional with Node.js, just because of that exercise. So long story short, I think it's not the usual path that somebody will take to write a book. I think I was extremely lucky to have this sequence of events that happened to me, and I wanted to take the challenge. But I think writing a book in general is an experience that you don't have to do just because you are an expert. You can do it even if you are not an expert. But then you need to be aware that everything you write, you need to spend a lot of time double checking it, asking for feedback, making sure you really understand what's going on. So it's going to take you a long time if you're not an expert to do that. In the end, it is worth it because you are going to come out of that experience with a much deeper understanding of that specific subject. So I do recommend that to everyone that it's up for the challenge.
Your development process as a developer, you have evolved as a developer, that's for sure. But like, this framework also has evolved. But like, most of the people might be having this doubt, and I too have this doubt. When is Node.js a single threaded, and when is it a multi-threaded one?
Mm-hmm.
Because we have seen lot of optimizations which have come up just in order to make this work very, very fast on the engine. But there are some processes where they can't debug it, so they are still in a doubt, like, when can we single thread it, when can we multi-thread this framework? So what's your answer for that?
I'm not sure I'm getting the question. Is when do you use a multi-threaded language, or in Node.js when do you use multiple threads?
Single thread and a multiple thread
in Node.js.
Yes.
Okay, so by default, Node.js it's single-threaded, meaning that you have one thread where your code is running, your code meaning the user code. Then, of course, you can rely on the underlying operative system to do concurrency. So every time you use I/O functionality, like read this file or send an HTTP request somewhere, it's actually the operative system doing that, and you get notified when that operation is complete. And this is what happens with the event loop. So most of the time, if you have a lot of I/O operation, your code is only waiting for this operation to complete. So having one thread, it's actually a very efficient way to solve the problem, because the amount of wait time, it's centralized in one thread, and the operative system is optimized to do all these things concurrently. So, and you don't have to think about how to make that happen. Like the operative system is doing that. There are more specific cases where maybe you want to have threads. And in Node.js, this was not possible originally to create your own threads. What you could do was to create a process. So you could spawn a child process and then kind of coordinate with that process or multiple processes if you want by sending messages. So you couldn't share memory. So that was also another option that was good. For instance, there is the cluster module available in Node.js in the core library, which allows you to make a web server much more performance by just spinning up multiple processes. And then when you get requests, that module will delegate handling that request to specific processes. And since every request is pretty much stateless in Node.js, it's fine. Like that works very, very well because you don't need to exchange a lot of messages or a lot of data between processes. There might be other use cases where you need to actually rely on the same shared memory. And today it is something you can do with worker threads. It is still a new feature, but I think there are already a bunch of interesting libraries that allow you to create multiple threads, coordinate those threads, use the memory, do locking if you need to do locking on that memory. So it is something that the language and the runtime is catching up with. Still, I have the feeling that Node.js it's a lot more relevant when you are doing IO-based workflows. Like if you really need to be CPU intensive, maybe there are other languages that are a better choice. Like you can still do it with Node.js if you have to do it just once and it's not your main business logic. But if that thing becomes your main business logic, I would probably recommend to look into other languages.
Yeah, no, Node.js is something which has unified the front end and the back end. You know, that's how this framework came into the picture. That's how this community came into the picture. You know, it was some developers who were frustrated about, just like you used to write just for a form, you used to write a validation code in the front end and a JavaScript and then a back end in the PHP. You know, it was so hectic. But like, how about the CPU and the GPU workloads that we can see through Node.js? Of course, it runs on a web browser. Even if it's on an edge, it's doable. But how is this CPU and the GPU workload being effectively optimized and effectively conducted in order to give an efficient result out? You know, there are people who are doing the machine learning using the JavaScript. You know, TFJS is there, deep learning for JS is there. There are a lot of things. So how is the CPU and the GPU workload being optimized using Node.js?
Yeah, I'm not an expert on this stuff, so my knowledge there is very like basic. So I might be saying something stupid. So I'm gonna keep the answer very abstract intentionally. But basically, what I see is that there are a number of initiatives that might be filling that gap of what JavaScript can do for these specific types of applications. For instance, one thing that I've seen coming up a lot is WebAssembly, which is not a specific JavaScript related technology, but it's one that you can interact very well from JavaScript. And you can even use it in the browser, you can use it in Node.js. So essentially, if you need to do very CPU intensive things, you could be writing a WebAssembly module, even in C or in Rust or in other languages that are more suited to write CPU bound tasks. And then you have a module that you can just use like a black box to say, from JavaScript, you can say, okay, now I'm going to delegate this task to the WebAssembly runtime, which is probably much more efficient than JavaScript is to run that CPU bound task. So that's probably one thing that we are going to be seeing more and more. And also I have this feeling that WebAssembly is going to become kind of a cross-language standard to release modules, where I am seeing that more and more languages are adding support for WebAssembly, meaning running WebAssembly modules in that specific language. So in the future, I think we will have, let's say, NPM for WebAssembly, where regardless if you're using Python, JavaScript, or other languages, you can just say, oh yeah, I know that this functionality exists in WebAssembly. I'm just going to import that module, and I will have an interface to basically deal with that module. So that's one thing that is going to be interesting. I think in the next 10 years, we will see a lot of that. Another thing that it's coming up in the browser a lot, I'm not sure if there is support for Node.js, is WebGL, that basically allows you to access functionality available at the GPU level through the browser and JavaScript. So, and that's something that I think some people are using in the front end to do, I don't know, face recognition or things
Sprites,
that.
Sprites based optimizations, like, in previous company where I was interning, they were using, it was an website which was supposed to take parts of a design and supposed to assemble according to the user. So they use most of the sprites, but like, sprites are too heavy in terms of browsers also. So yeah, that's where, yeah, I still remember that. Thank you so much for that. Sprites, I think sprites, yeah.
So yeah, WebGL is another thing that is coming up to kind of fill that gap of, okay, we need to do stuff that requires a GPU, but how do you access a GPU from JavaScript? So that's the kind of standard that it's coming up to fill that gap. But again, I'm not sure that is available in Node.js. Maybe it is. Don't quote me on that. But I think it's still a little bit early. We'll see more of that in the next few years for sure. So yeah, that's my very high level answer on. I don't think JavaScript is there yet, but maybe in the next few years the gap will be filled, and it can be a very reliable language and runtime to do also this kind of workflows.
Yeah, last question, Luciano, you have answered amazing, because I'm not a web developer, but I'm an application developer. I do most of my work starts with Flutter, because 2017 Flutter came in. I just saw it, but like during that time I was learning Android and I told, okay, this is not for me. Then when I saw Flutter, I fell in love with the mobile application development, and that's how my interest really started. But like, it's still an npm package, it's still a Node.js based application, the Flutter also. So like, what do you see the future evolution of this framework for the world? Like, how evolved it will be in next 20 years or 10 years? Like, in this framework, how can this framework evolve?
You mean Node.js, right?
Yes, and also any of the packages that you can give a reference to, and yeah, you can speak about them also.
Yeah, I think Node.js is still going to be there in the next 10 years. And the reason why I think that is because it's so entangled in a lot of different types of products. And I don't see any big competitor that might be replacing JavaScript and Node.js in all these products. So I think lots of big companies are still going to invest a lot in Node.js. Most likely Node.js is still going to be there in 10 years. What I think is going to happen, and this is something that has been happening already with, for instance, async await being introduced in the language, is that the language is going to get a little bit easier to write and read, because the async pattern, the non-blocking more than async, the non-blocking pattern is not something super easy to grasp if you are coming from languages where everything is blocking. And also sometimes it is hard to express things like, I don't know, sequential execution of non-blocking tasks. It is actually very, very hard to do that the first time that you are using the language. You need to learn a bunch of patterns. And that's actually one of the reasons why that book, Node.js Design Patterns, exists, because historically it was a little bit hard to do. It was way easier and more efficient to do some things, but at the same time, that was making harder to do certain things that in other languages are just obvious, like you don't have to do anything special. So my feeling is that there will be a lot of investment in terms of education, so making it more obvious how JavaScript works and making it also easier at the language level to express certain types of constructs. At the same time, I think there is still going to be investments to make the runtime faster and faster. And the next investment will be in interoperability with other technologies, like we said, WebAssembly, access to GPU. So yeah, I have a feeling that Node.js will be there. Another thing that makes me think that is, for instance, if you look at serverless, today Node.js is still one of the most efficient / easiest way to create a serverless function. I don't mean that in absolute terms, but I mean if you combine performance with how easy it is to express a serverless function in Node.js, I think that combination in Node.js is still one of the best choices. Other languages, of course, are competing all the time, like Python and Go probably are competing there. But I think today, if you want to do a Lambda in AWS, Node.js is your default choice. If you want to do it in Google Cloud, it's the same. If you want to do it in Azure, it's the same. So I think since everyone is moving more and more into commoditized access to resources in the cloud, and Node.js is becoming kind of a standard interface there, I think more and more companies, especially startups, or when you are building an MVP, will be using that model. So that's just going to make it more obvious that Node.js is going to stay there for a long time.
Thank you so much, Luciano, for this amazing podcast on JavaScript and Node.js. It was always that quest for me to understand all these technologies, because it was just a jargon for me before this podcast, actually. Not for a while, it was before this podcast. It was still a jargon for me. Now, after reading your book, I got a lot of satisfaction saying that, okay, this is no less than any programming language. But the thing is, like, we are still seeing it more complex, but we are not trying to make it much more simple. I think probably the last point which you said about educating people, making it more accessible and more readable, that's going to make this framework a huge deal tomorrow. I think thank you so much for clarifying all my doubts. I think probably I'm going to have a part 2 on this, because we still have to just get more of the Node.js and much more of the technical aspects covered, because I've read your book. I just want to ask my heart off and just get my hero clarify my doubts. So yeah, thank you so much, Luciano.
You're very kind. It was my pleasure to be here. So yeah, again, thank you very, very much for having me.